My name is Jason DeSica. I'm presenting on behalf of Team 3 for DP2, and I'm going to talk to you about our semester design project. Now, our project was designed for college students, and specifically college students that use reusable water bottles like this one here. Now, I love using a reusable water bottle, as do many other students and other people for that matter, but there is one pretty big problem that comes up with using these things that is annoying, and it's a lot easier if I just demonstrate it. So if you wear a backpack and you have a reusable water bottle, when you're walking around, it is pretty annoying to have to put your bottle away while you're walking. You have to really reach pretty far back, quite a stretch with your arm. And then if the pouch on the water bottle holder is elastic, you gotta stretch the elastic pouch out. And then certain bottles are like made of silicone and like a very frictiony material. And all in all, it's just like very difficult to get a bottle to slide into your backpack pouch. So our team wanted to come up with a solution and figure out how can we make this process easier. So we figured we could use some sort of mechanical solution that would essentially clasp a bottle in place. But before we jumped ahead and went right with some sort of gripping solution that I'll cover later, we had to brainstorm all sorts of different ideas and just come up with everything that we could possibly think of. So we used a couple of different brainstorming techniques for this. The first one being the 3-2-1 method. So this idea is that basically one teammate writes their idea down. They draw a picture of what their idea would be. So for one of them was like a clasping system, and then we pass the paper to the next teammate, and then they add to that idea, and we keep passing it around to get like a completely different idea that is essentially like a merger of all three of us rather than just one person drawing their ideas down. And this technique is pretty cool because it allows you to collaborate amongst three people and come up with an idea that may not have ever been come up with by one person alone. So we use this technique, and we also used another technique called a mind map. And a mind map essentially is like an explosion of different aspects of an idea that we would need to take into account. So if we wanted to do like an electrical solution, we would need a power source, so some sort of battery, right? Do we want a rechargeable battery, like a lithium battery in a phone? Do we want like a USB bank? Or do we want a disposable battery, like a AA battery or a 9-volt battery that you can buy from the store? If we don't want to do a electrical system, do we do a purely mechanical system? So where does the energy come from in that case? Does the user have to like do some sort of hand crank? Is there like a big button they push that like compresses a spring? Like how are we going to figure out how two claws can retract and open up? And do we even want claws to begin with? Do we want to do some sort of like claw machine system? Do we want to do like Velcro attachment or magnets or like an electromagnet that turns on and off and you stick something to your water bottle? So there's really like so many different ways that we could go with this. So the mind map was like a perfect tool to lay all those things out and get a good idea on where we wanted to go with different ideas. So from this brainstorming, we devised a poster called the gallery method. And the gallery method is essentially taking all of those individual ideas, like do we want a lithium battery or a rechargeable battery, and do we want horizontal claws or vertical grippers, and we combine each of those into viable solutions. So we came up with a bunch of different solutions, and some of those are a little bit more creative than the other ones. Some are very viable and some are very not viable for a consumer, but regardless, we still laid everything out and put it all on that poster just to see and get an idea of, what can we do with this, and can we come up with any new ideas from this poster or any inspiration. So we laid everything out on that poster, and we ended up narrowing it down to 3 options. With those 3 options, we have our first one, which is a purely electrical system. I mean, obviously all of these require mechanical clamps, but the actuation behind the mechanical clamps in the first one is a electric motor or a servo, which, servos just use electric motors in them. And then we use some sort of activation system. So we would need like a sensor that can measure proximity, because we don't want those clamps to always be in the closed position. I mean, that just makes the product useless. It has to know when the bottle is there, so that when you hold the bottle up to the side of your backpack, it has to know that it's there and for it to close the clamps around the bottle. So we need some sort of sensor to detect that. So there's like LiDAR sensors or sonar, there's like infrared proximity sensors. So we would have to decide what kind of sensor do we want. And then we would also have to decide the power source, as I mentioned earlier, and then what kind of motor do we want. And then so for our second solution that we narrowed down with the top three was the same idea as the first, that it would use a motor and a battery, but rather than the claws being out in front up above, they would come from the bottom. So if you've ever been to an arcade before and you've played with like a claw machine, those claws usually come from the top, and they aren't very strong, usually designed to be like that on purpose. But the idea is we would take that claw and make it upside down so that it essentially grips the bottle from the bottom. And the benefit of this is that the claws that grip on the bottom, it doesn't matter how tall your water bottle is, because it will always be held in place. Whereas if you have like one of those mini water bottles with our up above clamps, it wouldn't hit the mini bottle. It would, the clamps would be somewhere up above and it would be useless. So we thought about that would be a good solution. And then finally, we figured it would be worth putting a purely mechanical solution that doesn't require any electronics or battery or a motor or anything. And this is going to have its own downsides, but it also has pretty big upsides, that it's way easier to make. No electronics, no programming, no wires. So everything has its pros and cons. But from those three options, we had to figure out systematically which one that we wanted to pursue. So we used a scoring factor, or I guess I should say a selection criteria, that we weighted each criterion based on how important we thought each factor was. So our most important factor was the ease of use, and we weighted that at 25%. But then we also had, is it strong, and can it hold like a heavy hydro flask and hold a light plastic water bottle? I mean, those are two very different weight scales. I mean, an empty plastic water bottle is on the scale of a couple grams, whereas a heavy hydro flask can weigh a couple pounds. And so we also wanted to make sure it looks good, since this is going to be a device that goes on the outside of your backpack. It's very important that it looks stylish. People like to have stylish backpacks. We don't want to just make their backpack look terrible with a crazy looking device on the side of it. So how good does it look? Is it small and compact? And then also how much it weighs, because if we're adding a heavy device to the side of a backpack, the weight of carrying that thing around could very easily be more inconvenient than just sliding your backpack or your bottle in your backpack in the beginning, right? So the convenience has to be better than just a normal backpack elastic pouch for a bottle. So anyway, we went through and weighted each of our three options on all those factors, and we ultimately ended up finding out that our gravity powered solution was the best. So this is the product that we ended up pursuing. Now, it does have some downsides, but not requiring any electronics really makes it stand out, because we no longer have to worry about waterproofing those electronics. Electricity and water do not like to mix. We don't have to worry about programming a microcontroller anymore, and it really makes our system a lot simpler. So we have a final mock-up of what our CAD is supposed to look like and what the final product looks like. And the idea behind it is that so the activation method or activation system behind the water bottle holder, the gravity system, is that the base plate is not fixed in place, only the back plate is. So the base plate is able to move up and down. And that little bit of movement, when it detects the weight of the bottle, so you put the bottle on the plate and it moves down because the bottle has mass. So the plate moving down actually causes the claws to retract around the bottle. So it's a purely mechanical system. And the thing is, though, is that we need to make sure that the weight of the bottle, it can adapt for a super light bottle, like an empty plastic water bottle, as well as a really heavy bottle. And this is going to create some more complications down the road. But we figured that even with these complications of having essentially a floating base plate rather than it being fixed, it still outweighs having to deal with lots of electronics and programming. Thank you very much for listening to my DP2 presentation.